All right, today we're starting section 8.2. We will finish it up tomorrow. Our objective is to graph ordered pairs and linear equations in two variables. For our warm-ups, we are given a value for one of our variables and asked to solve for the other. So on that first warm-up, we are asked to solve for x if y equals 0. So I'm going to take that value for y and plug it in. So I rewrite the whole problem, 2x plus 3 times 0 equals 16. Instead of putting a y, I put a 0. I put it in parentheses because the coefficient right next to a variable means we have to multiply. Then we just start evaluating and solving. What is 3 times 0? So we have 2x plus 0 equals 16. What's 2x plus 0? 2x. It's not changing it. Who can raise their hand and tell me what to do to solve this? Jaquan? Very good. We divide both sides by 2. We get that x is equal to 8. All right, on the second warm-up, we are told that x is equal to 0, and we're asked to solve for y. So our 0 this time is getting plugged into the x. I rewrite the problem, replacing the x with a 0 in parentheses. The rest of the problem stays the same. What is negative 5 times 0? 0. Zero plus 3y. It's just 3y. Who can tell me how to solve this one? Ellie? And what do I get for y? Sure. Negative 6. It's got to be negative. So this is a skill that we're going to use a lot today. Here we have a coordinate plane. We've got some notes we're going to fill in below, but this will give you a diagram, so you need to copy this down. Alright, so there's a lot that we need to know about our coordinate plane. Most of this, maybe all of this, you probably already know, but we'll just go through a review of it. We've got these lines that cross here. The one that goes from left to right, we call the x-axis. The one that goes up and down, we call the y-axis. Can anyone raise their hand and tell me the name of that point in the middle where they cross each other? Keon? So the ordered pair would be 0, 0. We'll talk about that in a minute. Who can raise their hand and tell me? Ellie? The origin. So this point here where they cross, we call the origin. Alright, so we said we were about to name the quadrants. This quadrant on the top right, does anyone remember which one that is? Yes, both our x and y would be positive there. So x and y are both positive here. This is our first quadrant. We name our quadrants with Roman numerals. So we would name it quadrant 1. We name them counterclockwise, which means that the second quadrant is going to be to the left. So that's quadrant 2. Quadrant 3 is then below it. And then finally quadrant 4 is below quadrant 1. Remember, to make a 4 in Roman numerals, it's IV. And if we want, we can fill in what's positive and negative. So in quadrant 2, x is negative, y would be positive. In quadrant 3, x is negative and y is negative. And in quadrant 4, x is positive, y is negative. So if we are going above the origin, that's positive. If we're going to the right, that's positive. But if we go down or to the left, those are negative directions. All right, these are kind of our notes for today. An ordered pair is made up of two numbers. The first number is called the x-coordinate. The second number is called the y-coordinate. The ordered pairs tell you where to place a specific point on the coordinate plane. So in order to graph the point 5, negative 2, the first number tells us where to move in the x direction or along the x-axis. The second number tells us how to move along the y-axis. So in order to graph that, we are going to need to move right 5, then down 2. We always start from the origin. So that note at the bottom of this slide says to go left or right first, then up or down. So remember, left and down are negatives, right and up are positives. Now above that, it asks about the axes, which we labeled those on our coordinate plane already. Which axis went horizontally? Side to side, that was the x-axis. So horizontal was the x-axis. And which one went vertically? The y-axis. All right, on our first set of examples, we are going to graph the following points on the same coordinate plane. Label and state which quadrant each point falls in on the plane. So let's first work on graphing a point, and then we'll talk about which quadrant it's in. Remember that all of our points are x, comma, y. We move left or right first, then we go up or down. We always start from the origin. So from the origin to get to the point 1, comma 3, I need to go right 1 and then up 3, and that is where I will put my point. Right 1, up 3, and I label it point B. That is in the first quadrant, so I'm going to write a Roman numeral 1 by it. All right, who can help me out with number, well, the second one, letter R? Keon? Left 3, and then? Very good. Left 3, up 4. That is where we will put point R. And it is in the second quadrant. Very good. A new volunteer to help me out with point O. Ryan.
You just go down 3.
Go down how many?
2. Go down 2.
Good. Go down 2. So point O's x-coordinate is a 0. That means we do not move left or right. We just go down 2. So that is where we put point O. Now this one is not in a quadrant. It is on which axis? It's on the y-axis, so that's how we describe its location. If it is not in a quadrant, it's got to be on an axis. All right, point W. Ellie? Left 2, down 1. Sounds good to me. And it's in quadrant 3. Very good. All right, Jaquan, can you help us out with point N? Very good. We go to the right 4, and then we stay there. Very good. It is on the x-axis. All right, on example 2, we are asked to name the ordered pair for each point on the graph. So we are going to be listing out the ordered pair for all of them. We always start at the origin, and then we're going to have to figure out how to get to whatever point it is. So A, B, C, D, E, and F. So for example, for point A, if I'm figuring out how I'm going to get there, we move left or right first. I realize that it's on the line 1 space to the right of the origin. So I go -1 on the x-axis, and then I can go straight up to the point. To get up there, I would go up 1, 2, 3, 4, 5 times. So that point's location is -1, 5. I will give you a few minutes to try the rest of these points on your own before we fill in the answers. I need a new volunteer to tell me the ordered pair for point B. Natalie, is that a hand? 4, 3, I would agree with that. We would have to go to the right 4, and then we would go up 3. What about for point C, Carl? Negative. I think you're close. So how many spaces would we have to go left? 2. Left 2 spaces and then down 2 spaces. So I believe that should be -2, -2. All right, what about point D? Tariana?
Is it on the y-axis?
It is on the y-axis. That is not specific enough. We need to know exactly where it's located. Lexi? 0, -1. So if it's on the y-axis, your x-coordinate will be 0. And then we had to go down 1 to get there. All right, what about point E? Tariana for the redemption? 4, 0. Beautiful. If it is on the x-axis, your y-coordinate will be 0. And lastly, we have point F. Danielle? 3, -4. Very good. So we go to the right 3 and then down 4. An intercept is where the graph crosses an axis. There can be an x-intercept and a y-intercept. In most cases of what we will see for this chapter, you will have both of those. Not all cases, but most. Alright, here's where we get to the fun stuff today. We are going to graph this line using x and y intercepts. Again, this is something you've probably done before. We're going to do it again. So it might be important to note, just off to the side, up at the top somewhere, that if you are looking for your x-intercept, you are going to plug 0 in for y. If you are looking for your y-intercept, you're going to plug 0 in for x. So whichever one you're looking for, you plug 0 into the other letter. The way I've usually seen this set up is we kind of just separate it. We look for our x-intercept on one side. We look for our y-intercept on the other side. It's kind of like two problems in one. In the end, we will write these as ordered pairs. So our x-intercept is going to be a point. Our y-intercept is going to be another point. Okay, so let's give this a try. So we're using this equation to find my x-intercept. I'm plugging 0 in for y. This is kind of like a throwback to those warm-ups. That's why we did them. So we have 3x plus 5 times 0 equals negative 15. What's 5 times 0? 0. And 3x plus 0 is going to be 3x. So I'm fine on these ones. If that zeroes out and you just go straight to this next step where 3x equals negative 15, I'm okay with that. We should know 0 times anything is 0, and 0 plus anything is that same object, number, term. Then we still have to solve. I need someone to raise their hand and tell me how to get x by itself. I'll have to start picking on people because I'm seeing the same hands. Shannon? Divide by?
3.
Divide by a positive 3 because that 3 is positive. And Shannon, what do we get for x? Negative 5. Very good. But I said we needed to turn that into a point. What's my x coordinate? Negative 5. We said x equals negative 5. That is my x coordinate. What's my y coordinate going to be here? 0. If it's on the x-axis, my y-coordinate is 0, but also I plugged in a 0 in the very beginning. I said y is 0, so y should still be 0 down here. For the y-intercept, we have a similar process, except this time we're plugging 0 in for x. So we have 3 times 0 plus 5y equals negative 15. 3 times 0. Well, let's try that again. 3 times 0. 0. 0 plus 5y. Stays 5y. Somebody new, tell me how to solve this one. I'm going to pick on people. Kion, how would I solve this one? And what would I get for y, Kion? Wonderful. We divide by 5, we get y equals -3. So that is going to be the y coordinate of this point. What's the x coordinate? 0. We chose it at the beginning. If it's on the y-axis, the x coordinate has to be 0. Then we graphed both of those points. So that means my x-intercept is at -5. On my x-axis, I put a point at -5. -5, comma 0. That's that point right there. I'll make it a little bigger. For my y-intercept, I go to my y-axis. I'm going down to -3. I'm putting a point. And then we make a line through those points. We don't just graph the points and leave them. We actually need a line that goes through them. This is not great. We should have a straight line. First one was better. So use the edge of your ID or some other straight edge, a ruler if you have one. I find that the edge of your ID works nicely because you should have an ID anyway. But I don't want squiggly lines, so make sure you're using a straight edge for these. Alright, on example 4, if I want to find my x-intercept, I plug 0 in for y. So this becomes 0 plus 2x equals 6. 0 plus 2x. What do I end up with for x? Divide by 2 and I get x equals 3. As an ordered pair, who can raise their hand and tell me what it would be? Someone I haven't heard from. Start picking on people. Jakeem, what would my point be? 3-0. Sounds wonderful. Alright, to find my y-intercept, I'm going to plug 0 in for x. So I rewrite the whole thing, plugging 0 into x. 2 times 0. Y plus 0. Is just y. So I'm left with y equals 6. I don't have to divide by anything. If you want to divide off of 1, you can. It's not going to change anything. So as a point, Delaney, what do I get?
X is 0 and y is 6.
Wonderful. I have to graph those on my coordinate plane. So the point 3, 0, I go to the right 3 from my origin. I put a point. Find the point 0, 6. I go up 6 from my origin, and I put a point. I want to graph a line that goes through those 2 points. There we go. I want my line to go through most of, if not all of my graph, and I want it to have arrows on the ends. Example 5 was a little bit different. The problem was arranged a little differently. It has y by itself instead of x and y being together. But we are going to treat it the same way. To find my x-intercept, I'm going to plug 0 in for y. Now it's more important to leave that 0 there on this problem. It acts as a placeholder. In order to solve this, we start off by adding 8 to both sides. That's why we need that 0 there as a placeholder. 0 plus 8 is 8. What do we do next, Jaquan?
You divide each side by 4.
Wonderful.
2 equals x.
2 equals x, or x equals 2. And then we write it as a point or an ordered pair. Jamal?
If you're going to get the same answer, you have to add 8 to both sides.
I would be interested in how you got the same answer. What did you do?
4 divided by 8.
4 divided by 8 would be 1/2. Technically, there's one other way to solve this. We could subtract 4x from both sides and divide by a -4, and we would still get the same answer. But otherwise, this is probably our best bet. Tariana.
Okay, what I did was, you know how it was 0 equals 4x minus 8?
Yes.
I just brought the 4x down, divided it by 4 again. 8 divided by 4, I got 8 equals 2. That's how I did mine.
I'll have to look at your work. This is how we have solved equations in this class. So if you are mathematically showing your work correctly, I'll just have to take a look at it. All right. We still have not written our x-intercept as a point or an ordered pair. Ellie, what is it?
X is 2 and y is 0.
2, comma, 0. To find our y-intercept, we plug 0 in for x. Y equals 4 times 0 minus 8. What is 4 times 0? What is 0 minus 8? -8. As an ordered pair, whoop, we would have 0, comma, -8. Questions about how we found our intercepts? Then we have to graph the point 2, comma, 0 is here. It's at 2 on the x-axis. Our other point dropped off of our graph a little bit. 6, so it would be approximately right down here at -8 on the y-axis. Then we still have to put our line through those points. And put our arrows on it, and we've got that line graphed.